Hello, everyone. You're welcome to today's episode. Today is Tuesday, the 28th of September, 2021, and the project that I was planning for months now has arrived. Has finally I've got most of the, I've got 99% of the materials required for the project, which I'm planning to do. The project is consisting designing an electrical control system for a production line. And today, the inverter has been the big inverter, which was ordered, has arrived. So far, I was started doing the power part of the panel. So this is the mains, one of the mains contactor, and these are the protection for each of the motors. These are going to be direct online. 1, 2, 3, 4. 4 direct online motors will be run here, and this is going to be for the safety relays and for the safety circuit. It's going to control the safety circuit. This is going to be for the inverter. It's also a mains contactor for the inverter, and this is 24 volt. You can see these contactors, the coils are on 24 volts. Even this one, 24 volt AC. So this is a circuit breaker, and this is a fused breaker. So this is going to govern the whole panel. It's I think it's 80 amps fuse that's going to go in here. It's not installed yet, so I'm just planning it out. And this is a small inverter that's going to run another motor. There's another motor that's going to be run by this small inverter. So this is the inverter that I've been waiting for. It arrived today. It's massive. So I'm unboxing the inverter now. So Schneider finally delivered today. It has been on back order, and this is the space I reserved for it. I hope it's going to be enough. Looks like the space is enough. So this is how I plan the space, more or less. I've not fitted it yet. It's not. Just trying to measure out to make sure that everything is more or less how I planned it. I have not wired the control part, and I need to feed I'm going to feed the two inverters. I'm going to feed them from this contactor. I have a 16 square millimeters cable, which is going to be supplying them. I have this contactor here because this contactor is for the protection. When the PO safety relay trips, when there are safety issues or e-stop, it's going to interrupt this, and it's going to interrupt power supply to these two inverters. This is a small inverter. It's this is for a small motor. This is Altiva 320, ATV 320. This one is for a 2.2 kilowatt motor, Altiva 320, this small one. But this big one, I think it's a big motor that it's going to run a mill. And I'm going to explain to you now how the system is designed to run, because we are going to get this going as soon as possible. And they're not in a hurry to get it started. So this is going to be here this is going to be the feed of the whole panel. It's going to come from here, and it's going to feed the whole thing. And this is for for another smaller motor. This is a Guthridge that fits the mill. So it's important to control the speed of the Guthridge. The rest, 1, 2, 3, 4, are direct online motors. I'm going to use these relays for controls as well. to transfer, because my aim is to use a tachometer to monitor the speed of the mill. Once the speed of the mill has been reached, it will automatically switch on the rest of the machines. Hello, everyone. Like I was saying, this is what we intend to achieve. We want to design an electrical control system, automated system for a production line. This production line consists in a mill, and then another peripheral machines, like they're all individual machines. We have Guthridge, we have the infeed Guthridge, which is 2.2 kilowatts motor, and also, anyway, let me show you what the plans, what the electrical plans that I've designed for it. Here is the distribution. This is still work in progress. This was the fuse isolator I showed you before. It is a 100 amp fuse isolator, and this is the other isolator, which is an 80 amps isolator. And then these are the 1K mains and the 2K mains. These are the mains contactors that I showed you. From here, we're going to feed the power of the direct online control. There are four contactors that are doing direct online, and then this one is going to control. This is going to supply the two inverters, and then this is the transformer. The transformer, we use it for control, to control for the coils of the contactors, which are run on 24 volts, including they go through the add-on blocks also to supply to the control part of the system, control part of the panel. And this is the power diagram. Power diagram is here we have the 100 amp fused isolator. Then we have the circuit breaker, 80 amp circuit breaker, which I've shown you earlier. We have the mains contactor, 1K mains, and then this is the distribution. And here we have the four motors that are going to be direct online. You see, these are the protection, where we took I took the listing there. I supplied from the K mains. I supplied them so that once you interrupt K mains, they all lose power. And these are the contactors for each of them. This is a cyclone. It's KM1. It's a 5.5 kilowatts motor, 11 amp. It's a cyclone. What it does is that it chills the meal, and it also extracts heat. It extracts heat from the meal and keeps the meal from blocking. Extracts heat from the meal when the meal is running. And this is a sieve. The product that comes from the meal, it needs to pass through the sieve, and then it's to allow the certain diameter to pass through, certain dimension of the product to pass through. And this hopper is part of the under the feed Guthridge. So this is from the mill. When the product goes to the mill has grinded the product. It falls into the hopper. The hopper is a 1.1 kilowatt motor. The hopper moves it to a bagging screw. The bagging screw, what the screw does is that this screw transports it to the sieve. This screw will move it upwards. It's a 3 kilowatts motor. It's a bit more powerful. To move it upwards, and it will go to the sieve. And then the product will go from the sieve to go to other machines, the Flexicon, which are not represented here. We're only going to have going to put a start stop button on the Flexicon here, so it will have a remote start stop button. which will be implemented in the control side of this panel, but it's not yet included yet. So this is the power diagram continued. This is supposed to be the mill, the inverter of the mill. It's not well elaborated yet, and I'm going to this is still work in progress. So this is the other contactors, the other mains contactor, 2K mains, which is also going to be pulled down when there are safety issues. It's going to pull the two inverters down. So this is a small inverter which is going to run the infeed Guthrie. The infeed Guthrie is a small is a motor that feeds. It's a machine that feeds. It's a machine that feeds the mill. So once you start this machine, the product starts to go into the mill, flow into the mill. So this is the control part now. For the control part, of course, we have the transformer because we are running everything on 24 volts. We don't want to control it with high voltage. It's better to always avoid high voltage if you can, especially on the control side of things. So this is the control side, and then this is the add-on block. So the 24 volt comes here to feed controls of the cyclone. So how it happens is that how it works is that when you push the start button on the cyclone, the cyclone will start to run, and then the contactor will also close. The auxiliary, this contact 13 and 14 will close, and then when it closes, another contact as well, which is another contact, let's say 23 and 24, which is attached to the mill inverter. It's attached to the big inverter. It closes. This will allow you to be able to start the mill. If the cyclone is not running, you cannot start the mill because this is going to be open. It's not going to allow you to start the mill because this is done this way so that the mill does not block. So they want to make sure that the cyclone starts first and it's cooling the mill, then you can be able to start the mill. So this is the stop button. So this is the inverter, the big inverter that was supplied today, the 28th of September 2021. So how I designed this originally was that I'm going to incorporate an RPM switch. So I've tried to find a good RPM switch. What the RPM switch does is that it uses a capacitive sensor to count the revolution of the mill motor. So it's counting how many turns the mill motor does. So let's say, for example, the mill motor has 3,000 RPM as maximum speed. So this monitors it, and when monitors it through this sensor, this capacitive sensor. This is the feed for the capacitive sensor. Anyway, it was going to run on DC. Capacitive sensor was going to run on DC, so it's AC to DC inverter or transformer here. So it's supposed to be for the capacitive sensor. So the capacitive sensor is watching the motor of the mill. When the full speed is reached, it triggers this the RPM switch will trigger this small relay. So this small relay, once it triggers it, the contact of the small relay will start this contactor to start the sieve. It automatically gets the sieve going, so it tells the sieve to start, as well as it closes here also and tells the hopper. This is the one that's taken from the mill, tells us to start, that the mill is ready to start producing. Then this is the one under the mill, tells it to start, as well as it tells the one that's moving it across to the sieve, tells it to start as well. Otherwise, take note that the sieve has started first, and then the ones that the mill has started first, and the sieve is ready to start receiving, and then the machines under the mill has started first. Two machines under the mill also has started, and then This is KM4. KM4 is the one that is saying we're taking product away from the mill. Now we can start to feed. When this KM4 is active, that means everything is running. The mill is at full speed. The mill is at full speed, and the product, the outlet is clear. There are no safety issues either, because I have to put I put e-stops here, but do I have a safety have a separate safety have a separate diagram for safety system? I think it's better this way. So continue the control diagram. This is going to be this is not perfect yet because I'm going to work on it a little bit. So this is supposed to be the in-feed, the one where we feed the product in. So when the full speed of the motor is reached, then the product is going out, and it activates a timer. The timer closes this. We're not supposed to activate a timer, but I want to use a timer to make sure that it does not start immediately. So I might have to I'll make some changes here. This might not be necessary. CK1, this might not be necessary, So this might not be necessary. This might not be necessary. We might just use a timer to I just use the timer. You can just use the timer to can put a normally open this thing here. Another normally open contact there. Yeah, we can put another normally open contact here to make sure that the timer is closed before we can tell it to start. But all the same, it's not very necessary. Once the RPM switch, once the RPM speed is reached, which is shown here, we can start it. And this is not necessary either. This is just going to be a stop button. It's just going to be here. Just going to put a stop button here. I push button. Going to copy one stop button from here. Paste there. So this is going to be to stop the mirror, to stop the in-feed. So this is a stop button. I'm gonna make it so small so that it's not so big. Maybe too small. It's not too small. It's all right. So that's the stop. That's the stop. This is going to be the stop button. Normally close contact. It's a push button with a normally close contact. Just leave it here. All right. So this is the small inverter. So then the next we have the safety circuit. Safety circuit diagram. Safety circuit diagram is the PO safety relay. This is going to be control one of the contactors. This is one of the mains contactor. We're going to make another one in parallel. We're going to copy this one. And we're going to make another, create another one. This is going to be for Carmen too, for two Carmen. We're gonna put two Carmen here. So it's gonna be just about the same, just because it does the same thing. Yeah. Maybe he's gonna come from another of the POs, maybe 23, 24 of the POs. So this is gonna be 23, 24 of the POs. So it's more or less the same thing. No, this is not good. So we just connect it up there. These are the e-stops, the safety switches. So these are going to be in the machines. And once you push an e-stop, it will stop the machines will stop. Or once there's a safety issue, the machines will stop. So this is the reset, how to reset the system. So we're gonna have one. This is gonna be for 1K main, and then we're gonna have to do the same. Another one for 2K main. This is gonna be for 1K main. So this is what I'm working on now, and this is still a plan in progress. I have to label all this. I have to label all these diagrams, and most especially, and most importantly, I have to finish the implementation of the project. So don't forget to subscribe on my channel, to my YouTube channel, and click the like button to stay updated. And I'm going to keep you informed. And don't forget to check out other videos which I've done. And I'm going to show you more about how this project started. Here I have the list of materials that was ordered. This variable frequency drive, for example, which is here, variable frequency drive, which was ordered in, which came in today, is ATV 340 for 37 kilowatts. It came in today, and this cost about I think it's 3,200, 3,280, 3,280 pounds. It's 3,280 pounds plus VAT. That alone is quite expensive. So I'm going to take you step by step of how I planned this project, how I wrote the project, how I wrote the project plans and everything so that you can know how to execute a project. So don't forget to subscribe and see you on the next one. Bye bye.